Okay, the following equations represent straight lines. And we've got 5 of them there, notice. So it says, which equations represent lines that are parallel? And it says you've got to explain, right? So it's no good just having a guess, you've got to explain why. Now, it all goes back to our understanding of straight lines. Y equals mx plus c. And if you get it in that format, the m, of course, tells us the gradient, yeah? So what we need to do is rearrange all of these 5 here and see what the gradient is. And then the ones that have got the same gradient are the ones, of course, that are going to be parallel. Because remember, when it comes to parallel, they go in the same direction. Okay, so their gradients will be identical. So if we look at the first one, straight away the first one, well, the gradient's given for us, isn't it, practically? We can say here that m, the gradient, is equal to 4, okay? Because it's the value in front of the x there. Okay, we've got it in the form y equals mx plus c. The second one, we need to do a little bit of work with, okay? Now, it's not y equals, isn't it? It's 5y equals 10x plus 8. So we need to divide by the 5, okay? And when we divide by the 5, yeah? Because we take that 5 over, and times it by 5, so take it over and divide. When we divide this side by 5, we've got to divide each term by 5. So I'll have 10x divided by 5 plus 8 divided by 5. And of course then, 10 divided by 5 is just 2, isn't it? And then that will just, we can keep that as 8 over 5, okay? As a top heavy fraction. And can't simplify it. But 10 over 5 is 2, and we see then straight away, and then the gradient there is equal to 2, okay? Third line, okay, so we've got minus 6x plus 3y equals 9. So what I'm going to do there is, I'm going to, first of all, take the minus 6x over, so it becomes a plus 6x, okay? Minus takes it over, becomes a plus, and then of course you've got this plus 9. And then, you know, I'm almost there, but to get it in the form y equals mx plus c, I now need to divide, don't I? I need to divide by the 3. Okay, take the 3 over, divide. Okay, so I get y equals 2x there plus 3. Okay, 9 divided by 3 is 3. And there we see, look, our gradient is also 2. So straight away now, we can see we've got 2 lines that are parallel. This line here and this line. Okay, those two are parallel because our gradient 2 in both of them. But what we need to be careful of is we also check the final 2, because it says here which equations represent lines that are parallel. There could be more than one, so we need to be careful there to check that. So if I check then this penultimate one, 3x plus 4y equals 9. Okay, so I'll take the 3x over, so it becomes minus 3x plus 9, and then of course to get y on its own I've got to divide by the 4, so I get 3x over 4 plus 9 over 4. So in this case my gradient is equal to the value in front of the x, of course, minus 3/4. And then finally 24y plus 6x equals 7. So in this case now, keep the 24y where it is, take the 6x over, so it becomes minus 6x plus the 7, and then you divide by that 24. Now if you simplify that, you could simplify it on your calculator if you want, or you can see a quarter. X, that's 7 over 24. So m equals minus a quarter, the gradient there. And I hope you're satisfied now that the 2 lines that are parallel, these 2, because the gradient is 2, and then all the other gradients are all different. Minus 3/4, minus a quarter, and 4. Okay. Part B then, it says write down 2 of the equations that represent lines that are perpendicular. You must explain how you know that these lines are perpendicular. Well, we've actually done all the work now in part A, haven't we? We've done all the work in part A, and straight away I can see, right, the 2 lines that are perpendicular. Okay, we can see that line there, y equals 4x plus 3. It's got a gradient of 4, right? But if you look at this line here, the last one we did, the gradient is minus a quarter, okay? And those 2 have perpendicular gradients, because if you remember, with perpendicular gradients, the gradients are the reciprocal, negative reciprocal. So if you think about it, minus a quarter is the negative reciprocal of 4. Because 4 is like 4 over 1, isn't it? 4 is 4 over 1, that's what 4 is. So the negative reciprocal, you flip it, you've got that there. And we can actually prove it as well. We could just say, look, the gradients, when they times together, and I would write this down and make sure you note this, you get minus 1. And you just say, like, i.e., m1 times m2 equals -1. Just be clear you understand that idea there.